Good morning, one and all. So we are in module number two. We had been doing block reduction technique. So previous two lectures, which are already uploaded in your Google Classroom, you can find out the basic rules that we are applying for finding the uh, block reduction. So what is block reduction actually? If we see a very big plant, in that case there is controller, there is actuator, there may be a very big plant, and there may be many systems related to it. So if it's a very big plant and many blocks are entangled, then how to find out what is going to be the overall system transfer function? Why find overall system transfer function? Because once we find the overall system transfer function, that is ys by xs, where ys is the output and xs is the input, then ys by xs is a transfer function, that is polynomial ratio of numerator and denominator. So y by x we find. Then what we do is ys is equal to, so that xs from the denominator we shift to the right side. So Is is equal to Xs into the transfer function. Now Xs is the Laplace transform of the input. Now if I ask you to find out output for any kind of input, so output is called as response in technical term. We can find out for any kind of input. So input can be delta t. Delta t is the impulse. So in that case delta s is the Laplace. It is equal to 1. Input can be ut, that is the unit step. Laplace transform of that is 1 by s. So xs can be 1 if input is delta. Xs can be 1 by s if input is uh, unit step. Xs can be 1 by s square if input is ramp. So xs keeps on changing, and accordingly the calculations also will change. So ys is equal to xs into transfer function. So for various different inputs xs in the Laplace domain, we can find out what are the different ys. Now what do we do finding ys? After finding ys for different inputs, so ys will be different. From there we can take the inverse Laplace transform of ys, and we can find out what is called as yt. So all this game is happening because we want to find output equation yt for a set of different input. Okay, so different input can be unit step, impulse, ramp, parabolic, sinusoidal. So for all these different inputs, we can find out what is ys, because xs will be varying and ys will be varying accordingly. Then we find inverse Laplace of ys, that is yt, and we can find out the response. So one very important thing I told you while explaining what is the advantages of transfer function based method, and there we had said that transfer function based method or transfer function based system modeling. So what is meant by system modeling? Here we are finding the relationship between input and output through transfer function. So transfer function based system modeling does not depend on input, because input is taken as a xs. Okay, we don't know what is the xs. If it is delta, it will be 1. If it is unit step, it is 1 by s. If it is ramp, it is 1 by s square. If it is parabolic, then a by s cube. So input can be different, okay, and output also keeps on changing, but that right side, the ratio of output by input in Laplace domain, that remains same. So what is the best advantage of Laplace transfer based block reduction technique or transfer function finding? Main thing is, for different set of input we can find out what is the output. So output we can first find in Laplace domain, then we take inverse Laplace, ILT we call it, and it becomes time domain output. What we'll do today is, so two lectures, initial lectures I have uploaded in your Google Classroom, lecture number 9 and 10. I would expect every one of you would see or view that lecture, 2 hours lecture without fail today, because lot of numericals yesterday I had solved in lecture number 2 in the last half an hour, and you just keep on viewing that video time to time. And today again we are going to solve, first we'll do is one numerical which was solved yesterday. So yesterday we had used negative feedback, but today we'll use that positive feedback, the same circuit. Okay, and it is given in the book of M Gopal. So same numerical we will solve in two ways. In the first way we will see that we will shift the takeoff point in some way, and second case we will shift in between. So there are this very minute change, so you have to be very observant to understand exactly what are the two different methods That we will do today. So this numerical is taken from the book of M. Gopal, page number 110, 111. So after they have explained all the rules, after that, the same numerical, complex numerical, we have done the same numerical yesterday. That was the last numerical we had done. So same numerical we will solve again with different methods. And that two methods, if you understand these two numericals perfectly, almost 60 to 70% of your understanding in block reduction is done. Okay, and then again we will be solving a lot of numericals. So I'll bring my handwritten notes today again after we solve this two numerical, and we will be solving some over some 6 7 numericals we have planned to do today. So let us see what is the numerical we are thinking about, and the same numerical we will find in the book of M. Gopal. So this is a syllabus. I told you there are mainly three topics. The first topic is block reduction technique, finding transfer function. Second topic is finding transfer function by signal flow graph. And third topic is the stability analysis from the transfer function that we have found. So this is a circuit, okay, which we had done yesterday, but only difference was I think I had taken a negative feedback here. Okay, so I don't remember. It doesn't matter whether it is positive feedback or negative feedback, because in that case only the denominator sign changes. But what the main problem in this, looking at any system, first you have to understand what is the problem. Okay, what is the difficulty in that, so that we have to, so something is entangled. Something is entangled means one or two loops, एक loop दूसरे के अंदर घुसा हुआ है. Okay, so first we have to separate that out. So what is the problem? You can find here this H2. Okay, so this H2 is actually troubling this loop which where G2 is there. This H2 is troubling this loop where G3, G4 and H1 is there. Okay, so this H2 is actually the root of all evil. Because of this H2, you cannot solve it very easily. Just imagine the H2 was not there. So what is the question? You are supposed to find out Ys by Rs. Okay, and this is not a difficult numerical. I'm telling you, this is numerical which is having medium difficulty level. There are a lot of difficult numericals, so we will go there step by step. But yes, this numerical we will solve in two ways. In the first case, what we will do is we will see the what is the problem first, and then we will see what kind of solution we are proposing. So problem is this H2. Suppose H2 was not there. Just imagine H2 is not there. Then what? G3, G4 and H1, they are making a loop. Okay, suppose if H2 is not there, then G3, G4 and H1 is making a loop. And so this H1 is actually positive feedback. So if G3, G4 and H1, they are in a positive feedback loop, what would be their reduction? So if you just mix all G3, G4, H1 into one transfer function, what it would be? G3, G4 divided by 1 minus G3, G4 into H1. Suppose this H2 was not there, as H2 is there, we cannot do that because H2 is taken up in between G3 and G4. But if H2 was not there, that means this top feedback part was not there, then this numerical was very easy. So in that case, there was only two loop. First loop is this G3, G4 divided by 1 minus G3, G4, H1. That was the first thing. Whatever you find, multiply that with G2 because G2 is in cascade. Multiply that with G1, that is in cascade. So it would have been this thing. If H2 was not there, it would have been G1, G2, G3, G4 divided by 1 minus G3, G4, H1. So the whole forward path would have become like that. And then the whole forward path thing would have had a feedback of H3. So then the whole thing, whatever you are finding, that is G1, G2, G3, G4 divided by 1 plus or 1 minus G3, G4, H1, that would have been the forward path gain, G. And then this H3 was a feedback gain. So if the whole big thing in the absence of H2 we were saying as G, then it would have been G divided by 1 plus GH3. That was it. That was a numerical. But who is creating problem? In this case, the whole problem creator is H2. So there are two ways we can solve this. First way is take this H2 right side. That means shift this takeoff point to the right side. Okay, so this is the way we had solved this numerical yesterday. And if you are shifting this right side, what we are finding is here, after G3, whatever signal is there, we are taking it up. But if you're taking it after G4, that means this whole signal after G3 is getting multiplied and then you are taking the feedback. So in that case, in the H2 path, you had to do H2 by G4. I will repeat this thing. Here, after G3 we are taking the feedback. Now we are considering H2 and we are trying to solve this numerical. What is the first step? First method, take this H2 after G4. Okay, so if H2 is there just after G3, in that case this signal is whatever come up to this point, we are feeding it back to H2. But if you are taking it after G4, in that case what's happening is this signal, what is actually supposed to be fed back, this signal is again getting multiplied with G4 and then being fed back. Okay, so that should not happen. So in that case what we have to do is H2 had to be divided by G4. So this is what we had done last day. That first thing, we had shifted this H2 after G4 and we did H2 by G4, and then if this thing comes after G4, then all these loops are open now. So first we will solve this, then we'll multiply whatever we find here with G2, then that whole function is coming with in feedback with H2 by G1, and we will proceed. So this is the first step that they have done. Just check. Okay, so this image, I think it's visible. What they have done is, so it was this feedback point, so this was a takeoff point, it was after G3. Now they have shifted it after G4. Everything else is same. Okay, just see the image previously. So after G3 the H2 was taken. Now what they are doing is they have shifted this point after G4. And what is the change? Everything else is same, because H2 by G4 it is done. Why so? Because this signal was not multiplied with G4 and this signal was being fed back. Whenever you are taking the signal after G4, that means this signal is getting multiplied with G4 and then being taken back. But that was not the condition. Condition was for a feedback. But as you are multiplying this signal after G3 with G4 and feeding it back, in that case, to keep that balance, we have to compensate the multiplied gain in the feedback path. That's what we are doing, H2 by G4. This is a very common problem you have to understand. And this is the only thing. This is the only change if we do. That is, we are shifting this thing afterward. And this rule we have seen, that if we are shifting a takeoff point after a gain block, then whatever is the gain in that feedback path, that has to be divided by that G4. On the contrary, if we are shifting this point before G3, then H2 had to be multiplied with G3. Okay, so shifting a point after a gain block and shifting a point before a gain block. If you are shifting a point after a gain block, in that case your feedback gain had to be divided by that gain. Now somebody will say, sir, can I shift this point before G3? Yes, you can shift that. In that case, what change you have to make in H2 is H2 has to be multiplied with G3. So shifting after, feedback gain has to be divided. Shifting before the gain block, the feedback gain has to be multiplied. This is a very important thing. This is the only thing which we can find in this numerical, which you have to understand in this numerical. Everything else is very easy. So G3, G4 thing you have taken outside, and it has been divided with G4 that we have seen. And now you can see this loop is very open. Okay, so what is this loop? If you are next is you have to solve for this loop. So this is G3, G4 divided by 1 minus G3, G4, H1. So you can find here. Okay, so this steps you have to draw in exam, and generally you are having a habit of drawing by scale and all. If you start doing that, hell lot of time you will lose. So 1 hour you will lose in drawing all these block diagrams by pencil and scale and all. So what is the way? You have to draw it by freehand, but as straight as possible. So do not think of using scale at every step, because in that case huge amount of time have to be taken, have to be wasted. And very important thing is the direction of arrows. So yesterday I had shown you my handwritten thing. I missed the arrow in the main path. So this is called as the main forward path. That is R is the set point, G1, G2, G3, G4. This is called as a main forward path or main body of the overall whole block. Okay, and then there are feedbacks. So H1 is a feedback, positive feedback. H2 was a feedback, negative feedback. H3 is another feedback, that is called negative feedback. So this is 3 loop system. Okay, and main body is G1, G2, G3, G4. This is the main forward path. So what changes we have done first is we have shifted this point after G3 it was, we have shifted it after G4, and as we have shifted the takeoff point after a gain block in the feedback path, that gain should be divided. So whatever H2 was there, we are dividing it by G4. First thing, then this block it becomes, so now everything is straight. Now there is no entanglement. Now एक loop दूसरे के अंदर घुसा हुआ है, ऐसा नहीं है. All loops are very much open, and all these points are at the same point. इसमें कोई आगे पीछे नहीं है. yeah, because all are short circuit. So all these points can be shown as one line. Okay, so iske aage piche koi nahi hai. Okay, so all these points are at the same point. Now first what you solve is this loop. So G3 G4 divided by 1 minus G3 G4 H1, because it is positive feedback, that's why the negative sign is coming here. And after you are doing is you are finding that G2 and this solved thing are coming in what is called as cascade. So if you multiply this, it becomes G2 G3 G4 divided by 1 minus G3 G4 H1. So this multiplication also can be done, and then you are finding this is another loop. That is G2 G3 G4 by 1 minus G3 G4 H1 is now a forward path gain, and feedback, that is negative feedback gain, is H2 by G4. Now you have to again solve for that loop. So first loop is this you have solved. So after you have removed the entanglement, entanglements एक दो loops घुसे हुए हैं एक दूसरे के अंदर, entangled, okay, mixed kind of. So after you have removed the entanglement, first thing you have solved for this loop, you have found this, and then what you are trying to do is you are solving for this feedback loop. Abhi, now this thing is at the top, so don't think that ऊपर है तो feedback नहीं है, ऐसा कुछ नहीं है. Okay, ऊपर है नीचे है, all are feedback. So it doesn't matter whether it is shown up or shown below, it doesn't matter. You have to only check the direction of the arrows. So here it is only in the forward direction, all other things are going in the reverse direction. So first we have solved this first loop, G3 G4 H1 loop, and now it is opened, it is getting multiplied with G2. Now this whole thing is forward gain G, and H2 by G4 with negative feedback is the loop that you have to solve next, and you have done that. Okay, so once you have done that, so it is G2 G3 G4 divided by 1 minus G3 G4 H1 plus. So this plus is coming because this loop is a negative feedback loop. So as this is negative feedback loop, after multiplication, whenever you are putting H2 G4, so just see that this H2 term is coming to be positive because this is a negative feedback loop. And now you are finding that this G1 can be multiplied with it. So this is G1 G2 G3 G4 divided by 1 minus G3 G4 H1 plus G2 G3 H2. Now this thing is in negative feedback with H3. That means in this denominator again there will come a plus term with H3. Okay, and that will be the final loop that you are solving, and this is the final answer. So after this, so you are finding here that is this H3 term is actually coming with positive. So this H3 term is actually coming with positive because this H3 actually is a negative feedback, and whenever it is negative feedback, we know denominator it is 1 plus GH. So now the G is this, so what is the numerator term? G2 G3 G4 multiplied by H3. So you can find out here, and G1 is also there, I'm sorry. So G1 G2 G3 G4 multiplied by H3, so that term comes at the denominator. So G1 G2 G3 G4 H3. So one important thing you can see here is there is no S term here, so not necessary you have to write S. I solve with all S term, it is okay. If you are not writing S, that is also okay, but be very careful about which one is the positive feedback and which one is the negative feedback. That is the main thing you are supposed to observe. Okay, so now final line you have to write in the exam, that is the transfer function ys by rs. So I write R and C. Okay, they are writing ys by rs. So whatever is given in the numerical, you have to go with that notation. Okay, so ys by rs is the transfer function that is equal to G1 G2 G3 G4 divided by 1 minus G3 G4 H1 plus G2 G3 H2 plus G1 G2 G3 G4 H2. Now a very important thing you will see is now there are three loops. Okay, and all loops are touching each other. That is a very important thing. All loops are entangled because one loop you are solving, then only you can solve the other loop, then only you can solve the other loop. So there are three loops and all loops are entangled. You can find here all loops are touching each other. Okay, so this first and second loop, they are touching each other, second and third loop. So one loop you solved here, one loop you solved here. After you solve this, then you are going for second. After you solved first and second there, then you are going third. So likewise. So if the system is like this, actually I am preparing you for signal flow graph. Okay, what are the things to be viewed? Abhi se yaad rakho, because during signal flow graph again I will come back to this numerical and I will solve the same numerical with signal flow graph as well. So here we are finding there are three loops, okay, some with positive feedback, some with negative feedback, and all the loops are touching each other. Hence, in the denominator, whenever you are finding, you'll be finding only these three terms because all the loops are touching each other. Okay, so there might be a big system where there might be non-touching loop. These concepts will come in signal flow graph. So I'm telling you, whenever other people looks at it, they just solve numerical. It is not about solving numerical. It is about understanding what's actually happening in the system. So in this case, we are finding three loops with two positive feedback. That's why there are two positive signs. In this case, you are finding. Okay, so this is the second loop we had solved, which was this is the second loop actually, which was there. So there are two loops with negative feedback. You can find here there are two loops with negative feedback. So this is negative, this is negative. Okay, so we are calling this as the second loop, we are calling the below h3 as the third loop, and h1 is the first loop. So h1 is having positive feedback, hence that is generating a negative term in the denominator. So what all things we can find out from here is, in the forward path, if you're finding forward path is g1, g2, g3, g4. So things to notice is all the loops are touching each other. That is the first thing. Okay, forward path gain is g1, g2, g3, g4. So very easily you can find here. So again you are finding here that numerator is g1, g2, g3, g4. Okay, so this is the way, just by visually watching the numerical, you can find out what is the transfer function in one shot. That is in signal flow graph, and all the loops are touching each other. That's why in a numerator there will be four terms. Whenever all the loops are touching each other, this one will be there, one comes because of the formula, and there are three loops. That's why there will come three terms like this, and two loops are with negative feedback. That's why these two positive signs are there, because it is g by 1 plus gh in case of negative feedback, and one loop is having positive feedback. That's why it is minus sign here. So just looking at it, you can find out that the main body is having four gains, g1, g2, g3, g4, and there are three loops because there are three terms after one. So every numerical you'll be finding denominator, the first term will be 1. Okay, and this 1 minus g2, this thing, whole thing is equal to 0, is the called as a characteristic equation of the system. 1 minus all these things is equal to 0 is the characteristic equation of the system. Then we solve for s and we find what are the poles of the system, and from the poles, if we are finding in the left side of s plane, we say system is stable. So from this transfer function, what all we can find is main body is having g1, g2, g3, g4. So all these four things are coming at the numerator of the transfer function. Denominator is having four terms. So one is obvious term, leave it. Apart from that, there are three terms, and in three terms, two are positive. That means there are two loops with negative feedback, and there is only one loop with positive feedback. That gives you this negative sign. So these are the understanding you have to develop just by looking at the transfer function. Now, so same system. Now the same system we are solving, but by method 2. Okay, so this one numerical is given in the book of M. Gopal, and they have solved the same numerical by two different methods. So what is the problem here? What is the problem? Who is creating the trouble? Trouble is being created by this, that between G3 and G4 there is something which is called as a H2. Okay, it is causing the trouble. So what we are doing is, in this case, it will be something, a big twist. Okay, so you have to be observant to understand how you are solving this. How we are solving this? Okay, so what we are doing is, you can see this is actually a summing point. Okay, so the way we call it is, this is summing point 1, this is summing point 2, and this is summing point 3. Okay, what we are doing is we are actually bringing this summing point h1 first before g2. Okay, so this is the first thing. So actually they have done two steps together. So very interesting thing, just check. So summing points, if they're like this, they are so first thing they're doing is they're bringing this summing point h1 before this g2. Okay, you can say that g2 has been shifted after summing point. And we have seen, if we are shifting a gain block after a summing point, okay, then what happens is, in that case, this g2 has to be represented in the below wala thing with h1 by g2. So this is what is done. Okay, so this g2 is shifted after summing point, so this whatever is there, okay, that thing has become h1 by g2. This is the first thing. So in between there is another diagram that I will draw, and before I am uploading the slide I will show you that. So actually they have done two things. First is shifting the gain 2 after summing point, and then what they have done is they have changed the position of this summing point and this summing point. They have interchanged. So whenever you are interchanging summing point, no changes has to be done. So first thing is, this summing point is taken to the left of g2, or g2 has been taken to the right of this summing point 3. So this is the first thing, and they have exchanged this summing point 2 and summing point 3. Summing point 2 is connected with H2. You can see that. Okay. So the summing point 2 is connected to H2. The first intermediate diagram was this summing point 3. This is actually summing point 3. It was after summing point 2. Okay, so our first step is this point is taken to the right, then this H1 becomes H1 by G2, and next is this summing point 3 and summing point 2, they are swapped. Okay, they are swapped, and hence they are finding like this. So these are the two steps. If you have notebook, you can write down. First step is shifting the G2 block after summing point 3 SP3. Okay, that is the first step. And second point thing is SP2 and SP3, they are swapped. So now in this diagram below, so this is SP1, this is SP3. Okay, why this is SP3? Because check that this SP3 is having a positive feedback from H1 by G2. Check that this is SP3. Okay, so now the configuration becomes this is SP1, this is SP3, and then it is SP2. So there comes an intermediate step. I will draw the diagram, I will push here, and then it will be easier for you to understand. So first step is shifting G2 to the right of SP3, and second is swapping the position of SP3 and SP2. Okay, then you are getting this diagram. And whenever you are getting this diagram, now you can check that no entanglement is there. Why no entanglement is there? Because this G2, G3 and H2, they can be solved very easily. Okay, what is that? G2, G3 divided by 1 plus G2, G3, H2. Okay, so after these two steps, so first step is always difficult in case of block reduction technique. Once you remove this entanglement, now everything is easy for you. Okay, so first step is shift the G2 to the right, then SP1, SP2, SP3, and then interchange. So whenever two SPs are there, summing points are there side by side, you just exchange it with all the connectivities. Okay, so SP2 was connected to minus H2. You are finding this SP2 is connected to minus H2. This SP3 was connected to H1 by G3. Now this SP3 is connected to H1 by G3. So what I suggest is you read the book of M. Gopal. Okay, so it's in number 110. It is given. They have explained all the steps very easily. Or wait for my notes to be uploaded. I will draw that intermediate step, and then so two steps they have done together. That's what you might get confused. From here, suddenly how can we come to this? So suddenly it becomes very easy, but it is actually incorporating two steps. So if you are having pen and paper, write down. First step is shifting G2 to the right side of SP3. So whenever you are drawing this on book, notebook, or hand drawing, name this as SP1, SP2, SP3, and there is cross inside this. Okay, because this is can accept many inputs, so there are kind of quadrants drawn inside this SP. There is a summing point. So this is SP2, this is SP3. First is shift this G2 after, and next step is exchange the position of SP2 and SP3. So you come here, and after coming to this, there is nothing difficult. Okay, so now in this case, G2, G3, H2, they will be solved. So this is again the previous diagram. So whatever is there towards the end, the same diagram I have taken here in the next page, and then I'm solving it. So this is G2, G3 divided by 1 plus G2, G3, H2. So there is a standard formula with negative feedback. That is forward gain divided by 1 plus forward gain into feedback gain. So this is G2, G3 divided by 1 plus G2, G3, H2. Then this G4 is in cascade with this, they get multiplied, and then there is a positive feedback like this. So this is the second loop that you have to solve now. So the numerator is now is forward path gain is G2, G3, G4 divided by 1 plus G2, G3, H2. Okay, that is the G, that is the forward path gain. So divided by this whole thing multiplied by H1, G2. So that will be minus, because now it is positive feedback here, and 1 minus of all this multiplication. Okay, so numerator is this multiplication, G2, G3, G4 divided by 1 plus G2, G3, H2, divided by numerator 1 minus all this multiplication. So this is what you have to do. And now they reduce to this value. Okay, so why this minus? This minus is because of this second loop, and this loop is positive feedback. That's why this minus is coming in the denominator. Okay, and then why is this positive? This positive is because this above loop is negative feedback. So this is the first loop you are solving now. Okay, the same numerical we are solving in two different ways, and second case, the second loop is solved and we are finding a negative because this loop is actually a positive feedback. Then last This is H3, so now if you multiply this, so that is G1, G2, G3, G4 divided by 1 plus G2, G3, H2 minus G3, G4, H1. So this becomes now G, that is the forward path gain. So this whole thing at the numerator divided by 1 plus. Why 1 plus? Because this is minus sign. 1 plus G1 into H3 into this. That comes at the denominator. And if you solve it, you'll be finding that R is equal to G1, G2, G3, G4 divided by 1 plus G2, G3, G4 minus G3, G4, H1 plus G1, G2, G3, G4, H3. A very important thing they have done here is whichever loop they have solved sequentially. So first they have solved the positive feedback loop. That's why this plus sign has come here. Then they have solved the negative feedback, positive feedback loop. So first they have solved the negative feedback loop, that's why plus sign. Then they have solved the positive feedback loop, hence minus sign. And finally they have solved the negative feedback loop. That's why it has come to be plus sign. In the previous case, in the previous numerical, you can check here in the previous numerical, first they had solved the positive feedback loop. That's why there comes a negative sign. Then they had solved the negative feedback loop. That's why plus sign. And finally they have solved again a negative feedback. So previous numerical, first the positive feedback was solved, that's why 1 minus, then negative feedback was solved, then this is plus, and finally again another negative feedback, then another positive. But in this numerical, first we have solved a negative, then positive, then negative. Hence in the denominator, first come positive, this comes because of negative feedback, then there comes a negative because of positive feedback, and then there comes a positive because of negative feedback. So whatever you write in the denominator, sequence does not matter. But yes, if you are showing the sequence like this, it is easier for the examiner to understand. So whichever loop you are solving, that opposite of that sign. So if you're solving a negative feedback loop, sign should be positive. If you're solving a positive feedback loop, sign should be negative. And finally again you are solving another negative feedback loop, that's why sign is positive. So very methodically, one numerical is solved in the book of M. Gopal. Initially, afterwards there are a lot of solved numericals. I will assort all of them, and at the end of this chapter again we will have a numerical session. There we will discuss, and a lot of numerical I'll ask you to solve. And let me now remove this, and let me now go to my notes. Okay, whatever we had done, it is not very clean like this, whatever we have done here, but it is effective. So a lot of numericals we are now going to solve from that my notes. Let me just open it. So yesterday also we had done that. I think my notes is visible to you. So just check the same numerical. Just check the same numerical I'm showing to you. Okay. So this is numerical number 11 that we are doing. So this is a takeoff point. This is a takeoff point. Only difference is yesterday I had taken this as a negative. Okay, so this is negative further. This one I had taken negative, and this is negative. So all I have taken negative. But in this numerical in M. Gopal, what they have done is this H1 thing they have taken as a positive thing. So that is the only difference. That's why whatever numerical I solved yesterday, so yesterday in lecture number 10 towards end you will be finding this understanding. So as all are negative, you are finding that the same answer, but everything is positive here, because I had taken all the feedbacks as negative. Okay, that's why all terms in the denominator we are finding as positive. But in this numerical in M. Gopal, what they have taken is the first loop, H2 loop was negative, H3 loop was negative, but H1 loop they have considered as positive. Hence they are getting one negative term in the denominator. So those who might not have seen yesterday's lecture number 10 videos, so for them let me just give you a recap. So these are all the basic block diagram things. So two gains are in parallel. Sorry, this is GS and HS. So this is GS1 plus GSHS because negative feedback. GS and HS plus. So this is 1 minus GSHS. Then there we are actually inputting. So these are all my handwritten notes, very small things, processing I have put together. So this is x1, x2, x3, they are plus minus minus, so what they are getting, addition, subtraction. Then there comes the rules. Okay, so these rules I have explained in last two sessions with some numerical, specifically design numerical, you can just check. Then this is called a cascade. So what is CS by R is just multiplication of all them. And then this is number 7 is called as parallel. So input is given to all these three systems parallelly, and two systems are positive and one system is in subtractive mode. So CS by RS will be S by S plus 2 minus 10 by S plus 1 plus 0.5 by S. So this is parallel connection. So all these are explained in yesterday's lecture, lecture number 10. Please follow that. Okay, then a very easy system we had started with. So here there are two loop system, both loops are negative. Here you can find the denominator 1 plus G1H1 plus G1H2. So G1H1 is the first loop we have solved, G1, and whatever you find here, that is again having a negative feedback of H2. So here there are two terms you can find here apart from the one, and both are positive. That means only negative feedbacks are here in this system. So this was numerical number 8. Important, so this is again the same thing, so it's a very easy simple thing, but new terms are coined in this case. So one new term is G into H. So whatever is the, in any case of loop, if this is G1 and H1, just multiply the forward path gain and feedback gain. Okay, so whatever you have found here, CS by RS, this one for this system, this is called as a CLTF, that is closed loop transfer function. So for this given system, G by 1 plus GH or G by 1 minus GH, whatever you find, that is called as closed loop transfer function, CLTF. But for this loop, just multiply what is G into H, that is G1 H1, that is called as open loop transfer function. Very important thing, just multiply the gain of G1 and H1. Okay, don't take sign and anything, just multiply G1 and H1. So G1 H1 is called as open loop transfer function. What is the significance of that? When we will be going in the fourth chapter, or Bode plot and root locus, just from the open loop transfer function, that is G1 into H1, we can predict if this G1 and H1 are producing a closed loop system, whether that closed loop system will be stable or not. I will repeat the statement, it is important. G1 and H1 are the forward path gain and feedback gain. Just multiply them, G1, H1. Don't even take symbol, minus, plus, no need to take anything. From this multiplication, G1, H1, which is called as an open loop transfer function. From this G1, H1, we can predict whether the closed loop system produced by these two things will be stable or unstable. That's why just multiplying the forward path gain and feedback path gain gives us one new term which is called as G1 H1, which is called as OLTF, that is open loop transfer function. So here we can find out what is OLTF. It is nothing but 10 by S into S plus 2 multiplied by S square by 2 into S plus 1 multiplied by 60 by S. So first they have found what is called as closed loop transfer function. They have found it to be 9S by S square plus 3S minus 538. Then they have just multiplied GS and HS and they have found out what is called as loop transfer function or open loop transfer function. Previously CS by RS is called as a closed loop transfer function, and only GS by RS is called as a open loop transfer function. So just by looking at open loop transfer function, we can predict whether the closed loop produced by these two things will be stable or unstable. That thing is possible. 60 by S, you can see at the diagram, 60 by S. So 60 by S is called as a feedback. Okay, there is a feedback component, feedback ratio, and something very new important thing. So a lot of people are missing lectures. They are joining at the beginning and they're leaving in between. I'm telling you, don't do that, because every simple thing I'm telling you is different, and a lot of things we have to understand before we can go forward. So the whole lecture is important. Either listen here or listen afterwards. So ES by RS ratio. What is this thing? This is called as error ratio, and again this thing will be used in the module number 3, because there is a huge discussion in module number 3 on steady state error. In case of steady state error, we have to find this. So what is the formula for error in the system? Error is ES, that is RS minus BS, we have found out. So what is error? ES by RS, error transfer function or error ratio, is given by 1 by 1 minus GSHS. So if it is negative feedback, sorry, if it is positive feedback, in that case it will be 1 by 1 minus GSHS. It is negative feedback, it will be 1 by 1 plus GSHS. So accordingly, so remember this. Then we had come to this numerical. So there's a very easy numerical here. G2 and H1, they are in a loop first, and we solved it. Then we solved this G3 and H2, they are second loop, and here this is another loop. So we solved it, and we found the numerical to be like this. So a lot of numerical have been solved in yesterday's class, and this is a numerical where we stopped. And today again I have solved this numerical by two different methods. So what was the method here? So in today's session, initially I have explained the same thing to you. So this H1 is the problem. So don't get confused, because in this case I have taken it to be negative. So I have just changed only that much part. And in today's session, initially in the book of M. Gopal, whatever numerical I had shown, there it was positive. It doesn't matter, you should be able to solve it only. So this is the problem. So what I have done is, first I have shifted this signal to the right, and then G4, it has become H1 by G4. Now the entanglement is gone. Okay, now nothing is mixed. So you first solve this, and whatever you solve it, then that is multiplied with G2, and then solve this loop, and then whatever you get, multiply that by G1, that becomes a forward gain, and then you solve it by H3. So finally what you have got, the result as G1, G2, G3, G4 by this thing. Likewise you can proceed. Now you are solving, so another 10 minutes is there. Target is if we can solve some 2 or 3 numericals. So let us see. This is numerical number 12. So it's a 23 page note you can find. So almost 25 numericals or so have been solved. So all this, if you solve, I think you know all the different rules. So shifting takeoff point before, shifting takeoff point after, switching the or swapping the summing points, all the things are there in my notes in this 23 pages. So let us see. So RS is the input. So here you are finding that this G3 is not a feedback, because this is a feed forward thing. You are finding it. Okay. So what is the first thing? First thing we'll solve this. So G2 H1 is the first loop. So this is a very easy numerical. Okay, it looks very entangled, but this is a very easy numerical. First you have to solve this. So what is the thing? G2 divided by 1 plus G2 H1. You're doing that. So G2 divided by 1 plus G2 H1, and then G1 gets multiplied with that. So it becomes G1 G2 divided by 1 plus G2 H1. So this is this whole thing. This whole thing, if you're solving, you are getting G1 G2 divided by 1 plus G2 H1, like this. And then there is G3. So there are two gains in a parallel path. So what we do is we add them. Okay, if this thing is like this, the same input is coming, getting multiplied with RS G3 is coming here, and RS G1 G2 by 1 plus G2 H1 coming here. So actually we combine these two things and we prepare, that is G3 plus G1 G2 divided by 1 plus G2 H1. So this summing point 2, it is getting removed because you have to add that. And after that, the whole thing is getting multiplied with G4. So G4 into this. Now this is a very simple system. Entanglement is all gone. Now what you are finding is there is G4 multiplied by G3 plus this. So this is we are getting because there are two parallel paths. So parallel paths we have simplified, then we have multiplied G4 with that, and we are finding the whole thing is G, and this is H2. So now you can solve it, and after solving you have to come to this point. So don't leave numericals in between. Okay, so don't just say the output to be this divided by 1 minus this into this. So big term, sorry, that is not expected. You have to solve it, and you have to bring it in a respectable form. So this is what the solution we will be having while we are checking your paper. So try to bring your answer as close as this kind of look. Okay, then only this is having some significance. Now you can see, so I had made these notes quite before. So the shifting, source shifting and all these things. So source shifting, so RS and X, they are the source. Okay, so the same rules I have explained here. So the same thing we have done in previous class and all these things. So this rules we are not going to see. Directly we will see the numerical. The same thing you can see. So R is given to G and this is C. So C is equal to R into G. This was the takeoff point. Now we are shifting the takeoff point before. Okay, so we have to keep another gain G here. So these are actually shifting a takeoff point before a gain block. If you are shifting it before a gain block, then a gain has to be multiplied in the takeoff point. And if it was previous like this, so check this two thing now. Okay, now it was like this, and you are shifting it afterward. So if you are shifting this point afterward, then 1 by G has to be put here like this. Now you are coming to this numerical, very widely asked and very important.